What's up, skaters? Neil with Big Kids, and on this channel we talk about DIY tips, vendors, and the electric skateboard community. If you're new here, please consider subscribing and hitting that notification button to keep updated on videos like this one. Also, check out the show notes below for any information and links I leave in the description. This video is part 3 of my DIY electric skateboard build where I configure the VESC and the RC remote. But before I do, I'd like to mention the giveaway sponsor of this episode, BuildKit Boards. From sealed motors to battery packs, BuildKit Boards has quality parts at a fair price for your DIY project. If you haven't already, check out the online store, and for those of that entered the raffle giveaway from the last video, I'll be announcing 2 winners at the end of this video, so feel free to skip to the end. For the rest of you that want to see how to configure the VESC and the RC remote, let's go. The Vedder Electronic Speed Controller, or VESC, is a speed controller that revolutionized the e-skate scene. Before the VESC, the DIY community relied on speed controllers that were used in RC vehicles. The VESC, developed by Benjamin Vedder, is an open source controller made specifically for electric skateboards. What makes the VESC an awesome option is that you could configure your settings via a software called BLDC tool that Vedder developed. And because the VESC is an open source project, there are actually improved versions of the BLDC tool that were created by the DIY community. For this project, we're going to need the VESC, the BLDC tool, an RC remote and receiver, and a servo connector. Power up your board because the VESC will need current in order to be configured. Use a mini USB to plug into your VESC, and then connect it to your Mac or Windows computer. You'll then want to download the BLDC tool from the links below. So after you're all connected, you're going to want to open up BLDC tool. I have BLDC tool and the VESC firmware on this is 2.18, which is the correct version for my VESC hardware. My hardware is 4.12. They do have a Vesc 6 out as well, but you're going to want to check your VESC to see what hardware version it is. Then you'll want to connect to one of the COM ports. If you look up here in the upper right hand corner, you'll see the different ports that are there. In my case, there's just one. Sometimes you might see more than one up here, and you don't have to worry. You could choose either one and through trial and error find out which one is yours, and then just choose connect. If you look at the bottom, that will now show my status as connected. Once we're connected, we could now read the default configuration of what the manufacturer had sent this VESC configured at. So here we go. These are the default configurations, and the 2 things we're going to change on this motor tab is the the current limits and the voltage limits. Everything else we're going to keep the same. So let's start out with the motor max. The motor max is the maximum amount of current the VESC is supplying to the motor. A value that is too high will overheat the motor if it's over the max rated watts of the motor, as the motor can't withstand that amount of current. So to find the highest amp setting for your motor, we'll use this equation. Amps equals watts divided by volts. So take your motor's max wattage and divide by your battery's voltage. In this case, we're using the 6374 motor from Torque Boards, which has a max wattage of 3,150 watts. Our battery voltage, we can find out by taking the number of cells, which is 10, and multiplying that by the nominal voltage of each cell, which is 3.7 volts. So 3,150 watts divided by 10s times 3.7 equals 85.14 amps. So now that I know the max amps that my motor can potentially handle, I want to set it to a value below 85 amps just to be on the safe side. So I'm going to put it at 60 amps, which I think is a reasonable setting for my 63.7 motor. So now we're going to move to the motor min regen. Motor min is the amperage that will be generated and applied for braking. I weigh about 150 pounds, so I'm going to change the default setting. The lower the value when ignoring the negative sign will give you less braking pressure, while a higher value will give you more braking power. I'll set this to negative 45. I suggest testing different values until you're really comfortable with how it works for you. So now we're going to move on to the battery max. This value is the max number of amps that the VESC will allow from the battery to the load. So the load meaning your motor. What I usually do to find the max capability of my battery is to use this formula. Amp hours times the C rating equals amps. I multiply the amp hour rating by the C rating of the battery pack and then divide by the number of motors. In my case, I have a 5,000 milliamp battery, or a 5 amp hour battery, and I multiply that by 30C, and that equals out to 150 amps total continuous current. So now I divide that number by the number of motors I have, and then you have the max amps you can safely discharge. So now we know the battery's capabilities in regards to its max continuous current. 150 amps is more than enough to support the load. In this case, because the VESC has a 50 amp continuous current limit and up to 240 amp bursts, to be safe, I'll set my max battery value to about 50 amps. So now we're going to move on to the battery min regen. This value affects your braking at higher speeds as well as regenerative braking. So when braking, the motor regenerates energy that is sent to the VESC to be redistributed to the battery. To get this value, you always want to be safe to set it to charge at 2C of the capacity. In my case, I have a 5 amp hour battery times 2C equals 10 amps. So this doesn't necessarily mean you'll always be charging at 10 amps. So if this is not enough braking power for you, you can always set it a little bit higher, but to be conservative, I'm going to put it at 10 amps. Absolute max, we'll leave this alone. And what you're going to want to do next is to click Write Configuration. This will set those values to the write the configuration to the VESC, and these will be your new values. Make sure on the bottom right-hand corner it says that it has written, and we're going to move on. So let's move over here to the voltage limits. The minimum input voltage we could leave at 8. If you want to set it to be lower, that's fine too. My buddy at DELUXE, he sets his at 6 because apparently it helps when testing, but it really doesn't have a huge effect when you lower it. This 6, 8 should be fine. The maximum input voltage, we could leave that alone. And then the battery cutoff start this is a pretty important value. So like RC batteries have a voltage range of 4.2 volts at a full voltage, and then 3.0 volts for completely empty. The battery cutoff start is the voltage I want to start slowing down the battery as kind of like a basically like warning that I'm reaching the cutoff voltage. For your battery health, you do not want to drain the battery down to 3.0 or 0. What is recommended for battery health is that you do not go below 3.5 volts for LiPo batteries. I know for lithium-ion batteries you can actually go a lot lower than that, but for LiPos, 3.5 volts, going anywhere below that isn't recommended. So I usually set the battery cutoff to about 3.6 to kind of start slowing down. And then battery cutoff end is when the VESC reaches the input value. It will stop the board as if it's like out of power. In this case, I want to set the value to 3.5. Like I mentioned, I don't want to go below 3.5. You can if you want to increase your range, but going below that too often will shorten the lifespan of your batteries. So now that we have that, let's write the configuration again. So next up, we're going to do a motor detection, and the motor detection is done within the BLDC tab. So click over to that. The VESC will optimize its performance based on your specific motor settings. In order to do this, we'll want to go to the bottom left hand of the screen and then click Start Detection. You'll then see the motor spin, and you'll also hear kind of a strange sound. Once you've completed Start Detection, you'll notice some new values under the detection results right here. You'll want to move those values up to where it says sensorless communication mode right here. Under that, there are 3 fields: the integrator limit, the internal limit min ERPM, and the BEMF coupling. What we'll want to do is transfer the motor detection values to the corresponding fields under the sensorless communication. When inputting the values, it's best to round up to the nearest whole number. So in this case, integrator limit is 128.94. So we'll just bring this up to 130. In the ERPM limit, don't worry about that, leave that the same. The BEMF coupling is set to 756, so we'll just set that to 760. Then you're going to want to write configuration and make sure in the status bar in the lower right hand corner it shows that you've written, and we're good to go here. So let's step away from BLDC tool for a second and connect the receiver to the VESC as well as the RC remote and bind these together. This is the trigger style type of RC remote that I bought from DIY Electric. I'll leave a link below. And there are a lot of different types, so your process might be a little bit different, but this is kind of going to be kind of the basic process. So what we want to do here, and I've kind of gotten a head start, is you want to have a servo plug that you could also purchase pretty much from any DIY electric skateboard vendor. And we're going to be plugging it in to channel 2. You want to make sure that the neutral side is on the outside of channel 2, and the neutral side is always the black lead. So let's do that. Now that that's connected, we're going to want to connect this to the VESC. Now, just for example reasons, I'm going to show you this VESC. If we get up close, you could see this is right here. There's these 3 pins. There's these 3 pins right here, and that's where you're going to want to plug in the RC or the receiver servo. So that's what we're going to do. You're also going to want to make sure that the neutral line is facing out. And now that we've got that connected, you'll also need a binding loop key. This usually comes with your RC remote. So after you've gotten this loop key, you're going to want to put that into channel 4. There's no particular way to plug this in, so either way, whatever way fits. So if you see here, that's what it looks like. Now that we have everything in place, you take your remote, and this could be different for every different remote, but I'll be doing this for example, and you're going to want to hold down the pair button and turn it on. You'll see a red flashing light, and then you're going to want to turn on your electric skateboard, and you'll see a flashing light on the receiver. What you're going to want to do is wait till the red light on the RC remote is solid, and and then you're going to want to turn it off. Then turn this off, and you're going to want to pull the binding plug out, and we'll turn this back on and check it if it paired. There we go. Now let's get back to BLDC tool. So let's reconnect to BLDC tool again. I've plugged in my USB into the VESC and also into my computer. You're going to want to choose the COM port. In this case, again, just the one for me. Connect, and then check the low right hand corner in the status bar to make sure you're connected. We're going to configure the RC remote so that it's optimized, and the best way to do that is you're going to want to click on App Configuration tab, and then read the configuration that we currently have. Right now it's in PPM. PPM is basically any RC 2.4 gigahertz remote, so we're going to just keep it to PPM. You can also use PPM and UART or UART, Nunchuck. Those are all like different things, like the Bluetooth app that you could use. You could use the Nintendo Nunchuck, which was pretty popular at one time. But in our case, in this example, we're going to use the RC remote, so that's going to be PPM. I'm going to choose the PPM tab over here to get to the configuration. And before we move forward, I'd suggest that we disable this just so that it's not going to be connected to the motor at the moment, and just kind of keep noise down for now. And we're going to write configuration. So now the two values that we're going to be changing is the minimum and the maximum pulse width. And in order to get those values, right now we have them set to 1 and 2, which are just the default. We're going to have to test our RC remote. And so what we want to do here is click the display button, and this bar is basically you're going to see it go up and down when you hit the throttle on your remote. So in this case, I'm hitting down the throttle and it's going to 89%. So you want this to go up to 100%, and then when I hit the brake, it should go down to 0, which it is right here. If you look to the right of that, there is a value which we'll be putting in the minimum and maximum pulse width. Alright, so let's hit the throttle. And the value that we're seeing there is kind of a weird finicky value, but it looks like 1.89. So for the maximum pulse width value, instead of 2, we're going to change that to 1.899. Yeah, 89. And then we're going to brake, and that takes us down to the pulse width of 0.99. So we'll change that. And then when you're done with that, you're going to want to write configuration so that it writes it to the VESC. And now this should go to 100, and this will go down to 0. Perfect. So we're done configuring the RC remote, and what we want to do is get out on the road. But before we do, you want to click on current no reverse with brake. Click that and write configuration. And now that that's ready to go, you have connection to the motor from the RC remote. And let's disconnect from the VESC and get out of here.
Alright, so hope you found that tutorial helpful. Please keep in mind that you should use this video just as a reference. If you want to learn more about the VESC, go to the Electric Skateboard Builders Forum for more in-depth theory, troubleshooting, and ways to optimize your performance. And if you missed anything from part 1 or 2 of my videos, those videos are up on my YouTube channel as well. Now that you're prepared to build your own electric skateboard, what do you guys, the e-skate community, find most challenging? I'd love to hear from you, so post your thoughts in the comments below. And remember, if you join the Build Kit Boards giveaway from the last video, I'll be announcing the winner coming up. Always, thanks for stopping by, don't forget to hit that like button. And if you want to see more videos like this one, you can always subscribe. Take care and peace! Peace. Peace. Thanks again to our sponsor Build Kit Boards for offering these parts for a raffle giveaway. If you haven't checked them out, go check them out. We're going to start off by doing the 97mm flywheel clone giveaway, and we have a random name generator right here. This is my daughter Layla, and she's going to pick the name. Press right here.
Okay.
No, just press. And the winner is Evan M. Evan M, congratulations, you are the owner of some 90mm flywheel clones. So now we're gonna do these awesome motor mounts. These are great, they're one thick piece of aluminum. We're gonna be giving away 2 of them. And the winner of this is... And the winner is Manny Martinez. Manny Martinez, you just won a set of motor mounts. Congratulations. Say bye.